In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into validation in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 41. Oil and gas production, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization process, lecture number 41. Okay, before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my sayings. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Okay, oil and gas production. Oil and gas production introduction, facilities and processes, reservoir and wellhead management system we have already discussed, upstream facilities management systems, midstream facilities management systems, refining facilities management systems, petrochemical management systems, utility systems, unconventional, conventional resources and environment effects. Now we have already started. We are discussing this area. Okay, now we are discussing unconventional, conventional resources and environment effects. Okay, what is the ultimate goal? Shaping the clean and sustainable global energy. This is the first ultimate goal, and we have a plan to deliver more than 300 lectures next couple of years. Okay, gas production, unconventional and conventional resources and environment effects, lecture number 41. Biofuels, hydrogen, emissions and environment effects. So, key takeaway points from lecture number 41, biofuels, hydrogen, emission and environment effects we are going to discuss today. Biofuels. Biofuels are produced from specially grown products such as oilseeds or sugars and organic wastes. For example, from the forest industry, these fuels are called carbon neutral because the carbon dioxide released during burning is offset by CO2 used by the plant when growing. Ethanol alcohol, the ethanol alcohol that is C2, H5 and OH, that is ethanol alcohol, is distilled from fermented sugars and or the starch, for example wood, sugar, cane or beets, corn, maize or grape, to produce ethanol that can be burned along with retuning of engine or mixed with ordinary gasoline. Biodiesel is made from oils from crops such as rapeseeds, soya, sesame, palms or sunflowers. The vegetable oil, that is lipid, is significantly different from the mineral crude oil and is composed of triglycerides. In these molecules, three fatty acids. These are three fatty acids molecules are joined together here. So the Vegi lines, this is the Vegi lines, demonstrate represent the carbon chain with a carbon atom at each knee with single or double bonds and two, one or hydrogen atom respectively. So this also demonstrates the double bond. This is the double bond here and with hydrogen atom. Okay, so the biodiesel is made from oils from crops such as rapeseed, soya, sesame, palms, or sunflowers, the vegetable or lipids is significantly different from the mineral crude oil and is composed of triglycerides. That's important. We need to understand. Okay. Okay. Slide number 2, biofuels. The glass rule a backbone on the right side. If you can see here triglycerides here with the three molecules of the fatty acids. Okay, so it's bonding with OH hydroxide group here. Three fatty acids are, as you can see, it's the palmistic acids, olphic acids, and alpha linoleic acids, and a total carbon atoms of 55. The molecule is broken down to the individual alkali acids through a chemical process called the transrifications, whereas by the glycerine is separated from the fatty acids. So by adding a methanol, this is my methanol here, to the lipids and heated up, and strong base capable of deprotonating the alcohol such as sodium hydroxide and QH is used as a catalyst. The process leaves behind methyl esters, then it will become a methyl esters here. Okay, with CH3 group on the acids binding and glycerine, a valuable byproduct used in the soaps, explosive, and other product as well. Okay. Biodiesel contains no petroleum, but it can be blended at any levels with petroleum diesel to create a biodiesel blend. It can be used in combustion ignition diesels, engines with little or no modification. Biodiesel is simple to use, biodegradable, non-toxic, and essentially free of the sulfur and aromatics. Although biofuel is carbon neutral, concerns has been raised about diverting agriculture areas away from the food production. Recently, research has shown potential for growing certain strains in the arid regions that could not otherwise be used for the producing human food. An alternate to the above process that as we discussed, is still at the research stages genetically. So the modified colobacteria can produce enzymes to break down cellulose to sugar, which can then be used to produce a biodiesel. These methods allow use to general biological waste and limit competition with human food resources. Okay, hydrogen. Although not hydrocarbon resources, hydrogen can be used in place of as a complement to traditional hydrocarbon-based fuels. As an energy carrier, hydrogen is clean burning, which means that when hydrogen reacts with oxygen, either in the conventional engine or fuel cells, water vapor is only emissions. Combustion with air at high temperature will also form nitrous oxides. Hydrogen can be produced either from the hydrocarbons, natural gas, ethanols, etc., or by electrolysis. Production from the natural gas is often done via synthesis gas, as we discussed in my lecture number 36-37, with up to 75 to 80% efficiency. Disadvantages over methane gas is that the carbon dioxide can be removed and handled at central location rather than by each consumer, providing a cleaner energy carrier. Hydrogen is also produced from water by electrolysis with the efficiency of about 25% at normal conditions to about 50% high temperatures, high pressures process, or in various recycling process in the chemical industry. For example, hydrochloric acids recycled in the polyurethanes process. The energy supply can then come from renewable resources such as hydroelectric, solar, wind, wave, or tidal, where the hydrogen acts as energy carriers, replacing batteries to form fully clean renewable energy resources. And supply chain. In both cases, the main problem is overall economy. Distribution and storage hydrogen cannot easily be compressed to small volume and requires a quite bulky gas tanks for storage. Also, hydrogen produced from the electricity currently has an end-to-end efficiency that does not compare well with gasolines or electrical battery vehicles. Okay, so now from next level we'll discuss emissions and environment effects. Okay, emission and environment effects. The production, distribution, and consumption of hydrocarbons as fuels or feedstock are globally the largest source of emission in the environment. Okay, the total annual world energy supply of 11,000 million TOE is based on 81% on fossil fuels. and releases some 26,000 million tons of carbon dioxide plus other gases, methane, into the atmosphere. The most serious effect of these emissions is global climate change. The Intergovernmental Panel on Climate Change, often called the UN Climate Panel, predict that these emissions will cause the global temperature to rise from 1.4 degree to 6.4 degrees Celsius by the end of 21st century, depending on the models and global scenarios. That is mentioned how the emission and environment are affected. Okay, now the emissions from the industry can be divided into several types. First is called the discharge. Second, accidental spills. Third, emissions. And fourth, exposures. Okay, first, discharge. Mud, shale, silt produced water with the traces of hydrocarbons, blast waters, polluted wastewater with detergent, sewage, etc. Number two, accidental spills. Blowout, shipwreck, cargo and bunker oils, pipeline leakage, others chemical traces of low-level radioactive isotopes. Number three, emissions: CO2, methane, nitrous oxides, NOx, and sulfur from power plants and flared SOx. And number four, exposures, toxic and carcinogenic chemicals, etc. Okay, locally these emissions are tightly controlled in most countries by national and international regulations, and during a normal operation, emission targets can be reached with the system and equipped, as we have discussed in my earlier slide. However, there is a continuous concern and research onto the environmental impact of traces level of hydrocarbons and other chemicals on the reproductive cycles and health of the wildlife in the vicinity of the oil and gas installations. Okay, the major short-term environmental impact in from spill associated with accidents. These spills can have dramatic short-term effects on the local environment with damage to marine and wildlife. However, the effects limit out for more than a few years outside the Arctic region. Okay, so it also mentioned the most effective, that is how the greenhouse emissions gases is water vapors. Water naturally evaporates from the sea and spreads out and can amplify or suppress the other effects because of its reflective and absorbing capability. The two most emitted greenhouse gases emitted are the CO2 and methane because of its heat trapping properties and lapses in the atmosphere. Methane effects on the global warming from 20 to 25 times higher than the CO2 per kilo released to the atmosphere by ordering of importance into the greenhouse gases effect. CO2 emissions contribute 72 to 75% methane 14 to 18%, nitrous oxides 8 to 9%, and the other gases less than 1% sources, as we can also determine through the Wikipedia. The main source of carbon dioxide emissions is burning of hydrocarbons out of 29 billion tons, so as mentioned in many publications, of CO2 emitted in 2018 and 18 billion tons. Or about 60% of the total comes from the oil and gas. The remainder is coal, peat, renewable bioenergy such as firewoods. 11% or 3.2 billion tons comes from the oil and gas industry itself in the form of losses, local heating, power generation, etc. The annual emissions are about 1% of total atmospheric CO2, which is balanced with about 50 times more carbon dioxide dissolved in the seawater. This balance is dependent on the sea temperatures. Ocean CO2 storage is reduced as temperature increases, but increases with the partial pressure of the CO2 in the atmosphere. Short term, the net effect is that of about the half of the CO2 emitted. To air contributes to an increase of atmospheric CO2 by about 1.5 ppm annually. For methane, the largest source of human activity related to methane emission to atmosphere is from the rice paddies and anthrax fermentations in the ruminant animals, dung and compost from 1.5 billion cows and buffaloes. These emissions are estimated at 78.5 tg per year a source. as per FO out of a total 200 kg, which is equivalent to about 5,000 kg of CO2. Methane from the oil and gas industry accounts for around 30% of the emissions, mainly from the losses in transmission and distribution, pipeline and system for the natural resources. Okay, this was my last slide. So conclusion, what we have discussed today: biofuels, hydrogen, and emission and environment efforts. Next topic, we will discuss indigenous emissions. So few references here: Qatar Petroleum, Doha, Qatar, OGDC Pakistan, Oil and Gas Development Corporation Limited, Pakistan, World Energy Auto 2013, US Geological Survey, US Department of Energy, Schellenberger's Oilfield Glossaries, International Energy Agency, Wikipedia, Oklahoma State Management Commission Published Manuals, State Oil Fact Sheets, Norsex Standard, Norway, The Story of Oil in Pennsylvania, Air Liquid Gas Encyclopedia, Natural Gas from the Wellhead to Burner Tip. Together, everyone achieve more. Please do not hesitate to send me your feedback, comments, t.masood.dr@path.edu. I have also provided my WhatsApp number. You can also send me your info on WhatsApp. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed. Thank you very much.